let us see about the organic acids and bases, their pKa value and pH value. pKa, it is a tendency of a substance to donate its H+. And what is pH? It is a potential of hydrogen, or it is the tendency to measure the amount of H+ ions present in a solution. So both are completely different. Okay. Before going into organic acids and bases, let us see a small introduction about acids and bases. See, usually the earlier chemists, they define acid, that is any substance that has a sour taste is defined as an acid. Okay, because the acid came from Latin, that is, it's Latin, the acidus means it's sour. Okay, you know some familiar acids that is we use in our day-to-day life. We can see in our day-to-day life, that is citric acid found in lemons and other citrus fruits. Acetic acid, it is vinegar, and then hydrochloric acid that is present in our stomach, and that is called a stomach acid. And that is even we feel a sour taste while vomiting. We feel a sour taste. That sour taste is because of the presence of this hydrochloric acid, that is the stomach acid. So these are the familiar acids. And what are bases? So according to our earlier chemists, bases are substances that neutralize acids. Examples for bases are, that is all the wood ashes. After heating, we will be getting ashes. That ashes that is obtained from wood or from plant. These are all alkaline in nature. Okay, they are called bases. Here the word is from Arab, that is Arabic word. It is ash, means alkali. The word is alkali, that ash. This was. Okay, now coming, what are the things we are using as alkaline solutions? Usually in our home we will be using glass cleaners and the substance that are used as bleachers, that is sodium hypochlorite, calcium chlorohypochlorite, this is bleaching powder, and then that is used for unclogging drains, that is clogged drains are removed by using this alkaline solution. So these are the normal things, alkalis we are using in our day-to-day life. Okay, but later in 1920s, the definition for acids and bases was given by the scientists Bronsted and Lowry. These two scientists, they defined acid and base in a different way. They said that acid is a species that donates a H+, and base is a species that accepts a H+. So you can see in this picture HCl and water. Here HCl donates H+, and here this acts as an acid, and here water accepts H+, and it acts as a base. According to Bronsted-Lowry definition, any species that has a hydrogen can potentially act as an acid. Okay, see this HCl, water, here both have hydrogen, but even though this hydrogen is ready to donate H+, it forms a base here. So any compound, so this compound which possesses hydrogen is considered as an acid, and a compound that possesses lone pair is considered as a base. Okay, so both an acid and base must be present in this proton transfer reaction. So usually this acid base reactions are nothing but proton transfer reactions. You can see in this reaction HCl has donated a proton, and that is another compound, that is water, that is present. It accepts that proton and it forms H3O plus ion. So you can say an acid and a base will react to form again a base and an acid, and one must be there present there to accept the other thing. Okay, for a proton transfer reaction or acid base reaction, there must be an acid as well as a base which is ready to receive that. Okay, here when a compound loses a proton, the resulting species is called as a conjugate base. Here acid, you are having acid, and here is a water is a base, and this acid is converted to a base Cl minus ion, and what happens, this acid gives a base. Okay, so after the removal of H plus ion, it is converted to a base, and that base is called as a conjugate base. So if there is an acid, there will be a conjugate base. If there is a base, then there will be a conjugate acid. Here in this reaction, you can see acid. HCl acts as an acid and water acts as a base. HCl is converted to Cl minus ion, and that is a conjugate base. Here water is a base, and that accepts a H plus and forms an acid, and this is conjugate acid. Okay, so base, this is conjugate acid, and acid, this is the conjugate base. Similarly, see this reaction, ammonia with water. See, in the previous reaction, water has reacted as a base, but in this reaction, you can see water accepts water, donates H plus, and it is converted to OH minus ion. And here it is acid, and this is the conjugate base. And here base accepts H plus, and it is converted to an ammonium ion. Here this acts as a water instead of acting as an acid. Here it is acting as a base. So water can behave both as an acid as well as a base. Okay. Now coming to the other term, acidity. What is acidity? It is the measure of the tendency of a compound to give up a proton. And what is basicity? Just opposite to that. That is a tendency of a compound to accept a proton or its affinity towards a proton. Okay. Now then what will be strong acid? Strong acid is the one which has a strong tendency to give up its proton. So it is very ready to donate. Okay. This means that what is the mean? The conjugate base must be weak because it readily donates a H plus. So its conjugate base must be a weak base. See here in the picture you can see HCl, again the same example, HCl plus water giving Cl minus ion plus H3O plus. Here this acid is a strong acid and it gives a weak base, conjugate base. Okay. And here it is a, because it's a, this, why it is called as a conjugate base? Because it has little affinity for the proton. See how we can say this reaction is a weak base. See the arrow mark, the reaction is pointing towards right. So what happens? The reaction is the products are the main thing, main formed. But reverse it is, even though it is a reversible reaction, the reaction is shifted towards right. Okay. So this is a weak base. The weak, now why it is considered, why the, what happens to weak acid? Weak acid has a little tendency to give up its proton. So what happens? Its conjugate base is a strong one. Okay. So what is the relationship that exists between an acid and its conjugate base? The stronger the acid, the weaker is its conjugate base. If the base is stronger, then its conjugate acid is weaker. Okay. Now we'll move to organic acids, about organic acids and bases, and particularly about the pKa value and pH value. Now before going to that pKa, when understanding pKa, we must understand the equilibrium concept. See what happens is, see the first reaction, when a strong acid such as hydrogen chloride is dissolved in water, when HCl dissolved in water, what happens? It dissociates, or it ionizes, or it breaks into ions, so that the products are here. See the equilibrium arrow, here the products are shifted towards the right. So what is the meaning? The products are, the equation shifts towards right. What happens? So what the products are favored at equilibrium. So this reaction takes place very readily and the products are formed. Here see the second reaction. Here this is acetic acid. Acetic acid, it is considered as a weak acid. Why? Why it is considered as a weak acid? See the arrow mark, see the equilibrium. See here the reaction, the arrow mark is shifted towards the left. Okay, so what is the point is, here only very few molecules dissociate and so the reactants are favored at equilibrium. Now products are not favored, instead reactants are favored at equilibrium. So why we have to understand this? Then only we can speak about the strength of the acids. Okay, now you can see whether a reversible reaction favors reactants or products at equilibrium is indicated by the equilibrium constant. How will you write the equilibrium constant? It is K equilibrium. Now you can see a simple reaction which that is HA donates refers to acid and water and it gives H plus. Here water accepts H plus and so it is converted to H3O plus, and acid donates H plus and it is converted to a conjugate base A minus ion. Now how will you write K equilibrium? It is the mass of the concentration of the it is the product of the concentration of the products divided by the product of the concentration of the reactants. So concentration of H plus ions plus into A minus ions divided by water into He. Okay. The degree to which an acid dissociates is normally determined in dilute solutions. That is very important. Okay. So what you have to consider, the concentration of the water always remain constant, and so we have to remove that, or we can say that this will be, we can remove that H2O, or you can put the value K H2O. The concentration of H2O will be 50.55 moles. Okay. So Ka is equal to H3O plus into A by HA, or we can say that is equal to K equilibrium into water, and this Ka is nothing but acid dissociation constant. Okay. And what happened now? We can say what is this pKa. Now we can define pKa. See, pKa is nothing but the negative logarithm of Ka, acid dissociation constant. Okay, so the larger the acid dissociation constant, the stronger is the acid. That is, it is greater tendency to give up a protons. Okay, now I think you can understand what happens. That is, the pKa is nothing but it is the measure of the tendency of a compound or tendency of an acid to donate its proton. Okay, and we have to measure it using the negative logarithm of Ka value. Okay, see the value for I have given for HCl and acetic acid. See the Ka value for HCl, it is 10.7, and the pKa value, it is nothing but the negative logarithm of Ka, so it is -7. And here acetic acid, it is 1.74 in 10 to the power -5, and the value pKa value is 4.76, and you can say that smaller the pKa value, stronger is the acid. See, you can see the pKa value. See the pKa value of HCl, it is -7, so very low value, so it is a strong acid. But see, acetic acid, it is nearly 4.76. Okay, so somewhat it is not, it is very stronger, it is somewhat weak acid. Okay, so you can see this tabular column so that it will be easy for you to understand. Very strong acids, the pKa value will be very less than, it is less than 1. Moderately strong acids, the pKa value remains from 1 to 5. Okay, if the weak acids, the pKa value remains stands from 5 to 15, and if they are extremely weak acids, very weak, then the pKa value will be above 50. Okay, so remember in mind, that is pKa value, if it is low, then it is a strong acid. Okay, you can see. Now, okay, you keep it this pKa. And what is the pH? Given the difference, that is pH is the past potential of hydrogen ions, or we can say the amount of hydrogen ions present in a solution is pH. Okay, so how to determine that pH? It is nothing but the negative logarithm of hydrogen ion concentration. And I think you know all these things. That is, your acidic solutions, you always have a pH value less than 7, and the basic solutions always, that is, the alkalis always have a pH value greater than 7, and the pH of the solution can be we can change the pH values. Okay, simply if you are adding HCl, if you are having concentrated HCl, the pH will be very low. If you are having a dilute HCl, the pH will be somewhat higher. Like that, you can change the pH values. Okay, so don't confuse always pH and pKa. pH scale is always used to describe the acidity of a solution. Okay, but pKa is a characteristic of a particular compound. It is a unique feature of a compound, like a melting point. If you have a compound, then it has a unique melting point. It has a specific melting point, specific boiling point. Like that, they have specific pKa value. Okay, so that is the difference between pH. pH we can change for a compound. Acetic acid, you can say you can change the pH, but you cannot change the pKa value. Okay, that is the main difference between pH and pKa. So you can see the values. Some values I have given, that is for a strong bases, the pH values will be greater than 7, that is that nearly 13. You can see the household bleach what you are using is sodium hypochlorite, and that's value is nearly, it is 12.5, and you are having egg white, the value is nearly neutral, that is 7.6 to slightly alkaline. And then seawater, if you see, it is 8.1. You know what is the pH of a human blood? It is slightly alkaline. It is 7.35 to 7.45, and milk, it is 6.4 to 6.8. Saliva, it is slightly acidic. Rainwater, it is slightly acidic. Why? Because of the dissolved carbon dioxide. And you can see in the picture, that is tomatoes, that is the acetic acids present. Tomato, wine, cola, vinegar, lemon juice, gastric juice, these are all, they have high pH values. Okay, this is simply for your understanding. Now I will ask a question. Okay, can you see which is a stronger acid, one with a pKa of 5.2 or one with a pKa of 5.8? You can answer. Yes, what is that? We have seen that the pKa value is low, then it will be a strong acid. If the pKa value is high, it will be a weak acid. So the acid one with the pKa value 5.2 will be the strong acid, and the pKa 5.8 will be considerably weaker than the previous one. Okay. There is one more question. Which is a stronger acid? One with acid dissociation constant 3.4 into 10 to the power minus 3, or acid dissociation constant 2.1 into 10 to the minus 1. So you know, if the pKa value is low, the Ka value must be high. Okay, so among these two, which one is a high value? 3.4 into 10 to the power minus 3 is a high value, and it will be a strong acid, and the 2.1 into 10 to the power minus 4, that will be a weak acid. Okay. There is one more question. Say an acid has a pKa Ka value. The Ka value is given 4.53 in 10 to the power minus 6. And what it is? K equilibrium. They have asked the question. And here the water, that is the concentration of water, we have to consider as 55.5 moles. Okay, because it is the that is one number of moles is 55. How to calculate is number of that is volume by that is molecular weight. So volume 1000 divided by the molecular weight 18. So you will be getting the value as 55.5. Okay. There is one more. Find the pKa value for this also. See, you know this equation. Yes, Ka is equal to K equilibrium into water. No, so substitute the values and you can find out the answer. And see here the answer, it is the question K equilibrium is 8.6 into 10 to the power 18 and pKa is found to be the value taking anti-logarithm, or you can use 10 to the power minus value, and then you can find out, and the answer is it is 5.3. and you know 5 to 10 it is a weak acid. Okay, so it is a weak acid. Okay, thank you. We'll see the rest in the next video. Thank you.